Okay. Good morning. Can you hear me? But I was late. There was power cut early morning. Okay, now okay. Let's start. Okay, we discussed last day. Last week, what we discussed? The specific latent heat and its calculations, right? Specific latent heat and its calculation. Okay, I'll revise what's the meaning of specific latent heat and latent heat again. Okay. The latent heat, we did the calculations as well, right? We have three main equations to calculate the quantity of heat. Quantity of heat mean what? The amount of heat absorbed or released by any object or system, right? The quantity of heat. We have three equations. If there is only temperature difference without any physical state change, Q equal mc theta or Q equal c theta. mc theta for specific heat capacity, c theta for heat capacity, right? The final equation Q equal ml, Q equal ml, this ml equation for physical state change without any temperature difference. Physical state change without any temperature difference. Now, what is the meaning of this latent heat or specific latent heat? Latent heat, hidden heat. Do you remember the definition? The latent heat. Yeah, the latent heat means any physical state change. The amount of heat absorbed or released in any physical state change. Think solid convert into liquid. That's melting, right? Solid convert into liquid. It is melting. Solid substance convert into liquid. If you think ice, 0 Celsius ice convert into 0 Celsius water. That's the melting of ice. The boiling point of the melting point of water or ice, it is 0. The melting temperature is 0 Celsius, right? Now 0 Celsius ice convert into 0 Celsius water. Now no temperature difference in this physical state change. The amount of heat absorbed, is a latent heat. Latent heat, right? Do you remember? The amount of heat absorbed in any physical state change without any temperature difference, right? Without temperature difference, the amount of heat absorbed or released we called as latent heat. Latent heat without temperature difference. Yeah, according to, then we discussed about specific latent heat. What's the meaning of specific latent heat? Specific mean we discussed in the previous. Specific mean in unit mass. Unit mass. The specific latent heat means the amount of heat required for unit mass of 1 kilogram of solid substance. 1 kilogram of solid substance at melting point 0 Celsius. If it is ice, 1 kilogram of solid substance as 1 kilogram of solid substance at melting point to completely convert into liquid state. 1 kilogram of water, liquid, that means water, the amount of heat requirement without any temperature difference, right? That one also 0 Celsius, right? That's a specific latent heat. Specific latent heat. I gave you two definitions for specific latent heat: specific latent heat of melting and specific latent heat of vaporization, right? Am I correct? You meant? Now, any physical state change, you can prepare the equation and definition. you can get the equation, the amount of heat absorbed by unit mass of substance to change the physical state from one physical state to another physical state without any temperature difference. හරි. ඔය ටික මම මේ ගිය සතියේ ටික මතක් කරේ. We have homework, no? Homework question. What's the question number? I gave homework. Vihinga. What is the homework question number? Oh, not this one. Seven question part 2. Yes, the first part we can discuss today. Yes, 100 gram of small ice cube at minus 10 Celsius. It is minus temperature. Completely convert into 110 Celsius water vapor. It's a long process, right? Minus 10 ice to vaporize, convert into water vapor at 110 Celsius. The first part, draw the thermal curve for above heating process. The thermal curve we can discuss today. First part only. Let's do later. Then second part, calculate the heat requirement for the above heating if no any heat loss. If no any heat loss, specific heat capacity of water is given, the specific latent heat of vaporization of water also given. I told it is plus 6, right? It is plus 6, not minus 6. Specific latent heat of ice of melting is given. Hadu. Okay. Now what is the 7 part 2, right? Question number 7 part 2. What is the physical state change? Now first starting from minus 10 Celsius ice. First, this minus 10 Celsius ice convert into 0 Celsius ice because it is a melting point of ice, right? 0 Celsius ice. Next step, 0 Celsius ice convert into 0 Celsius water that we call as melting. 0 Celsius water that we call as melting. That's a physical state change. You can see there is no any temperature difference. I told any physical state change, there is no any temperature difference because the absorb or release heat make bonds or break down bonds. If it is absorb heat, that means endothermic process, endothermic physical state change, melting wage by the endothermic physical state change, breakdown in bonds. If it is exothermic means freezing type exothermic physical state change, they making new bonds using this release heat. Releasing heat, they making new bonds. But endothermic one, melting they break down their bonds. Now solid mean like this. Solid mean they have highly compacted, very strong intermolecule bonds. Highly compacted, very strong intermolecule bonds. At when it is reached to melting point, they are kinetic energy vibrations reach to maximum with these intermolecule bonds. Bond velantin, they already bonded, they compacted, right? At 0, when it is reached to 0 Celsius, increase their kinetic energy and reach to maximum level, right? With these strong bonds, cannot increase kinetic energy more than that. They can meet kinetic energy bonds nisa, right? Highly compacted. Due to that, what happened? Absorb, utilize some part of heat energy. This absorbing heat, then don't water when melt when, yeah, they absorb some amount of heat and they break down their part of bonds. Part of bond breakdown, right? That we called as melting. since they utilize this provide heat for bond breakdown process, heat use bond breakdown. Therefore, the temperature is same in the physical state change, right? The temperature will not be changed, right? Is it true? Are you good? That's the meaning of physical state change. Now, solid means they are highly compacted. In the physical state change melting process, what happened? They convert into medium level intermolecular bonds like this. They break down in part of their bonds, right? And my bonds break down karna, that we call as physical state change. Physical state change means melting. They are highly compacted using part of heat energy, break down their bonds, part of bonds, then it is converted to medium level strong intermolecular bonds that we call as liquid. Okay. Harneet. Nabil. That's a physical state change. In vaporization also same story. I'll explain vaporization as well. Vaporization means nowadays convert to liquid. It is 0 Celsius water. 0 Celsius water. Now they have enough space to vaporize. Enough space to increase kinetic energy as liquids. එතකොට liquid විදියට මෙයාට kinetic energy එක වැඩි කරගන්න පුළුවන්. No problem. But when it is reached to 100 Celsius, when it is reached to 100 Celsius as liquid, when it is reached to 100 Celsius temperature, 100 Celsius means boiling point of water, that is a maximum kinetic energy as liquid. I told 50% bonds, they already have medium level intermolecular bonds, right, of liquids. Then what happened? This 50% also break down in the vaporization process. In the vaporization process, these molecules convert into freely available bonds, very weak intermolecular bonds, May 50% to break down kernel. Then they convert very freely available molecules, right? That we called as vaporization. That's the physical state change. That's why in the physical state change, this provided heat absorbed by molecule and break down their bonds, not increasing the temperature. That's why we call as the amount of heat absorbed in the physical state change is latent heat. Right? I think now you got the full idea last week. Process now minus 10 Celsius ice convert to 0 Celsius ice, that's the melting point. Then 0 Celsius ice convert into 0 Celsius water. Now it is melting is done. Now 0 Celsius water convert to 100 Celsius water, because no any physical state change. 0 Celsius water to 100 Celsius water, no physical state change. 100 Celsius is the boiling point of water. Then it is converted to 100 Celsius water vapor. 100 Celsius water vapor. Finally, that we call as vaporization, right? Vaporization. Any physical state change, no temperature difference. Right? Finally, it is converted into 110 Celsius vapor. 110 Celsius vapor. Yeah, 110 Celsius vapor. Right? This is the process. Now, the question is the amount of heat requirement. Q equal minus 10 to 0 Celsius. There is a temperature change. Then MC theta plus 0 Celsius ice to 0 Celsius water, that is a melting. It's a physical state change. No any temperature difference, ML, plus 0 Celsius water to 100 Celsius water, there is a temperature difference and no physical state changes, MC theta, plus 100 Celsius water to 100 Celsius vapor, again physical state change, ML, 100 Celsius vapor to 110 Celsius vapor, again MC theta. Understood? මෙතෙන්ට එනකන් තේරෙනවද? Yeah. හරි. Now මෙතන okay right? ඔයාලා හදපුවා හරිද? හරි. Now the mass of ice cube, it is 100 gram, no? 100 gram mean you have to convert in kilogram, it is 0.1. 0.1 kilogram. 0.1. The specific heat capacity of ice අපි හොයාගන්න වෙනවා. The specific heat capacity of water is given 4200. Then ice value also same. 4200. Ice mean water. 4200. Temperature difference minus 10 to 10. Sorry, minus 10 to 0. What's the temperature difference? 10 or minus 10? Vihinda. What's the temperature difference? 10 or minus 10? 10, yes. 10 is the temperature difference. I told don't take minus value for temperature difference. Right. The first one, okay. Right. The mass 0.1 kilogram. The specific latent heat of melting. Now you have to find the specific latent heat of melting of ice. The specific latent heat of melting, it is given 3.6 into 10 to the power 5. 3.6 into 10 to the power 5. Right. The second equation done. Right. Now mass 0.1. Specific heat capacity of water 4200. Temperature difference. Then අපි මෙතන ඉන්නේ මේක හරි. This one okay. We are in the third step. 0 Celsius water to 100 Celsius water. What's the temperature difference? 100. 100. Plus. මම මෙතන ඉන්න. Now third equation done. Okay, again vaporization. This one. Vaporization. 0.1. L, specific latent heat of vaporization. The question given, the specific latent heat of vaporization. It is already given. 2.2 into 10 to the power 6. 2.2 into 10 to the power 6. ml, vaporization ml also done. Final one, final step, 0.1 into vapor specific heat capacity also same water, 4200. Temperature difference 10. Temperature difference 10. Okay. If you got the value of Q, you can find the heat requirement. Now 4200. Okay, let's solve one by one. 4200 into 0.1. It is 420. It is 4200 again. Method value 0.1 into 3.6. It is 0.36. 0.36. 36,000, right? Correct? You know, 36,000. Yeah. Okay. The third bracket, 0.1 into 4200, 420, two zeros. Right? Fourth bracket, 0.1 into 2.2. It is 0.22. එතකොට අපි 2 දෙකක් දාලා 1 2 3 4. Right? අර හදලා බලන්න. 0.1 into 4200, that means 420. 400, 4200 again. Huh. That's the answer. Now you can add these values. Q equal, add color. What's your answer? What's your final answer? Are you correct? Make a harika then will correct? Human? Dulen? Answer wrong mean, I think you used -1 here. Within a -6 they use correct. It's okay. It's okay. දීලා තියෙන use කරත් අවුලක් නැහැ. But that's a mistake. මේ printing mistake. It's +6. No, I want if you got these steps. මෙන්න මේ equations ටික ගත්තා නම් 1 2 3 4 5 equations perfect. ඒක පුළුවන් නම් okay. මේ calculation is no problem. Who got this equation? Raise hand. මේ second step එකට වෙනකම් හරි අය උස්ස. Only Dino? Okay, good. Okay, this if you that's a heat lesson, right? That's a heat knowledge. The substitution and calculation, it's mathematics. It's math. What's the value? 306,402. That means Q equal 306.4 kilojoule. Kilojoule. Nabil, understood? Isru? Hi. Okay. Write down the topic in your short note. What's the final topic we did in short note? Specific latent heat of vaporization, right? Yeah. Specific latent heat of vaporization. Write down the main. Next topic in the short note. Thermal curve. Thermal curve. Thermal curve. Thermal curve. Okay. Right. Thermal curve. Okay. Thermal curve. Okay, this is the meaning of thermal curve. A thermal curve is a graph showing how a temperature change of any substance with time while while heating, absorbing or releasing. Right? Think now actually this may temperature. Now think this is a substance. This is a substance. Now think initial temperature 30 Celsius, right? Initial temperature 30 Celsius. If it is heat absorb, if it is heat energy absorb, how to change the temperature of this substance with time? That's a thermal curve. It's a graphical relationship. It's a graphical relationship to show the relationship between temperature and time and how to change the temperature with time of this substance, right? That's a thermal curve. It is actually not a curve, it's a graph, but the name is apikani tapaja vakra kila, thermal curve, right? But it is a graph actually. Okay, let's draw thermal curves. Before that, let's write down the main definition. Okay, write down the definition. Write down star mark. A graph, a graph, a graph represent the relationship, represent the a graph represent the relationship of temperature, relationship of temperature, relationship of temperature of any substance. A graph showing the relationship of any substance with temperature. Temperature change with time. Temperature change with time. While heat absorbing or releasing. While heat absorbing or releasing is called as thermal curve. Right? The same definition. Make it a graph showing the relationship between a graph showing the relationship of temperature change of any substance with time while heat absorbing or releasing is called as a thermal curve. Okay, this thermal curve like this. It's very simple graph to show the relationship between time and temperature. The temperature change with time, right? Now, think first example. First example, uh, 30 Celsius water, right? 30 Celsius water, heat up to 100 Celsius water first. 100 Celsius water, that means boiling point. Then it is converted into 100 Celsius water vapor. 100 Celsius water vapor. 100 Celsius vapor convert into 120 Celsius water vapor. Okay, this is a made temperature change. Temperature change. The thermal curve made, it's a graph to relationship between temperature and time. Temperature and time. Remember this graph always, the y-axis is temperature, x-axis time. X-axis always time. Y-axis temperature. Y-axis temperature. Right. Now at time 0, now this is origin. Origin means 0, comma 0 on both axis, temperature 0, time 0. Right? Think this is a 30 Celsius. This is a 30 Celsius. This is 100 Celsius. 100 Celsius. It is 120 Celsius. Right? At time 0, initial temperature 30. Then we have to start from this point and increase temperature up to 100 Celsius. 100 Celsius like this. Increase the temperature up to 100 Celsius like this. Gradually temperature increase up to 100 Celsius. Right? At 100 Celsius, what happened? At 100 Celsius, it takes some time for physical state change, right? These are 100 Celsius level, these are 120 Celsius level. At 100 Celsius, it takes some time without temperature change for physical state change, right? Like this. It takes some time without temperature change for physical state change. This is a physical state change that we call, now it is 30 Celsius water, right? 30 Celsius water. At this level, 100 Celsius water, it is 100 Celsius vapor. Actually, this is a physical state change. This is a physical state change. Physical state change means it is vaporization. 100 Celsius water, 100 Celsius being boiling point water convert into water vapor without any temperature change. Without temperature change, it is converted into vapor. This is the vaporization. This is the vaporization. This is the vaporization. After vaporization, that means when it is converted into 100 Celsius vapor, it's again gradually increase up to 120 Celsius. 120 Celsius. Okay, this is a thermal curve for above temperature difference. Understood? If there are any physical state change, it takes some time without any temperature change, right? Now 100 Celsius, it takes some time for bond breakdown process. Understood? Okay, that's a thermal curve. It's a graph to show the relationship of temperature change with time. It's graph to show the relationship of temperature change of any substance with time while absorbing or releasing heat. Now it is a heat absorbing process. Let's see what happened in the heat releasing in next one. Right? Clear? Right. Isru? Nabil? Afsal? Yeah. Okay, write down first example. Example number 1. Thermal curve after definition, write down the first example. "30 Celsius water, 30 Celsius water convert into 120 Celsius water vapor. 30 Celsius water convert into 120 Celsius water vapor. Draw the thermal curve. Draw the thermal curve for this temperature difference. Draw the thermal curve for this temperature difference. Draw the thermal curve of Draw the thermal curve for this temperature difference of the water. Draw the thermal curve for this temperature difference of the water. Hurry. First, write down this temperature difference path and draw the thermal curve. In thermal curve, always x-axis time. Remember, y-axis temperature. That's always same, right? Remember. Dulen, what do 9 mean? First lesson of the 9th lesson. 9th lesson. Okay. The thermal curve is it's a graph. Okay, Dulen. Send me WhatsApp message. I'll solve your problem. Okay. Yeah, the thermal curve is a graph. It's not a curve actually. It's a graph. If it is named even curve, it is not a curve, right? It's a graph to show the relationship of temperature change with time. The temperature change of any substance with time, right? While absorbing heat or releasing heat. Remember the definition. This definition is not asking, but keep some idea. Better to have some idea, right? Okay, complete. It is 30 Celsius water. First convert to 100 Celsius boiling point water. Boiling point water vaporization without temperature change. Then it is converted to 120 Celsius water vapor. Right? 20. In the exam, do they give time also or just temperatures? No, time no need. Time දුන්නත් අවුලක් නැහැ මේ වගේ time දාන්න තියෙන්නේ. එහෙම දීලා නැහැ. You the idea you should have, they take some time without temperature change in a physical state change. That's only you need to remember. In a physical state change, they take some time, right? Without temperature change, same temperature. මේ time එක ගන්නවා. This time to think it is 5 seconds. Now it is 10 seconds. This 5 seconds, 5 to 10 seconds for physical state change. Okay, let's do another one. It's complete, right, Priyanka? Now, finally, it is 120 Celsius vapor. 120 Celsius vapor. Okay. Second one. Second one. 5 kilogram of ice. 5 kilogram of ice cube convert to 70 Celsius water. 5 kilogram ice cube convert into 70 Celsius water. Draw the thermal curve for this heating process. Heating process. Draw the thermal curve for this heating process. Okay, this is example number 2. Hi. Sorry, the 5 kilogram ice cube at minus 10 Celsius. 5 kilogram ice cube at minus 10 Celsius convert into 70 Celsius water. Now, okay, 70 Celsius water. Draw the thermal curve for this heating process. Hari, can you draw this? It's very simple. Again, the thermal curve is a graph to show the relationship of temperature change of any substance with time, right? Okay, this is my x-axis. X-axis means time, sorry. Time. Y-axis always temperature. Temperature. Y-axis temperature. Hari, can you draw this? Simple. Yeah, better to write down the path. Minus 10 ice. Minus 10 ice. Minus 10 ice. Minus 10 ice. First convert to 0 Celsius ice. Why? It is a melting point. 0 Celsius ice. It's a melting point. Now 0 Celsius ice, 0 Celsius water. Melting, right? Water. Now 0 Celsius water convert to 70 Celsius water because no any physical state change, right? This is a temperature change. Right. Now where it is starting? Kohen the start very. You went. Where does it start? This is a 0, 0 origin. Yeah, below the 0. Good. Think this is a minus 10. Minus 10. It is 0, minus 10. This temperature line, it is the y-axis, temperature axis. And this is 0. And this is a 70. 70 Celsius. Right. Now, first 10 Celsius ice convert to 0 Celsius ice. Right. Gradually increase temperature up to 0 Celsius. The 0 Celsius is a special case. It is a melting. It is a melting. It takes some time without temperature change, same temperature, right? Finally, when it is converted into water, the temperature again gradually increase up to 70 Celsius. 70 Celsius. Right. This is the thermal. It is 0 Celsius ice, 0 Celsius water. This is a melting process, water. It is 70 Celsius water. 70 Celsius water. Right? Understood? Any doubt? Isuru? Nabil? Too late? Any doubt? Right. Okay, third one. Your third ticket. Third one. Yeah, it's a special case. You have to more careful. 150 Celsius, 150 Celsius water vapor. Water vapor cool down into 30 Celsius water. 30 Celsius water. Draw the thermal curve for above cooling process. It's a cooling process. Okay, for this cooling process, actually it is gas convert into liquid. It is condensation. Okay, is it heat absorbing process or heat releasing? Given. Is it heat absorbing or releasing? Now 150 Celsius water vapor convert into 30 Celsius water. It's a cool down process. Is it heat absorbing, the water heat absorbing or releasing? Yoni? Yeah. No, I asked heat absorbing or releasing? Yeah. Heat releasing. Good. Because it's cool down. Yes, heat releasing. Good. Okay, draw the thermal curve. Hari, Andim. Draw the thermal curve for this cooling process. Okay. First of all, you can note the temperature change path. Okay, first starting from 150 Celsius vapor, 150 Celsius vapor, convert to 100 Celsius vapor because it is a boiling point vapor. 100 Celsius water that we call as condensation water. 100 Celsius water. 100 Celsius water to 30 Celsius water, right? Okay. Now you can draw the thermal curve. It is same. The y-axis is temperature. The x-axis is time. Temperature. How to draw this? Starting from, yeah, initially, that means time 0. What is the temperature? 150. හරි ඔයාලා අඳින්න බා. I'll give you 2 minutes. Okay, this is the 150 Celsius. It is 100 Celsius. Think this is the 30 Celsius. Right? Now where it is starting from 150 Celsius vapor to 100 Celsius vapor, like this. Now time increase to this direction, right? Time එක යනවා. Right. This is a path. Are you correct, Dinod? Right. Good. Okay, then it is 100 Celsius water, 100 Celsius vapor. 100 Celsius vapor take some time without temperature change to change the physical state. Right? And to change the physical state. And when it is converted into 100 Celsius water, again cool down to 30 Celsius water. Now this is 100 Celsius vapor, 100 Celsius water, 30 Celsius water. Dulain, what is this physical state change? What's the name of this physical state change? Dulain? 100 Celsius vapor converted to 100 Celsius water. What's the name of this physical state change? Very good. Isuru, what's the name of this physical state change? through, what's the name of this physical state change? No. I asked 100 Celsius vapor convert into 100 Celsius water, and that's a physical state change. That means gas convert into liquid. No? What I mean liquid. What's the name of this change? මෙයාට අපි නමක් කියනවා. What's the name? That we called condensation. Condensation. Good. Did not correct. Condensation. Condensation. This is a physical state change. Okay. Okay, you have to watch our previous recordings. You have recordings, right? Recordings still Dirante? Yes. Oh. කලින් ටික අනිවාර්යෙන් බලන්න ඕනේ next week. If not, it's this lesson very difficult. Yes, triangle one. Yeah. Yeah, in the triangle we discuss 6 physical state changes. Melting, freezing, melting, freezing, vaporization, condensation, sublimation and deposition. Hari. Now let's moving to question number 7. Question number 7 එකේ part එකක් තියෙනවා. Yeah. 100 gram of small ice cube at minus 10 Celsius completely convert into 110 Celsius water vapor. Draw the thermal curve for above heating process. Hari. Note down this question as example number 4 in your book. 100 gram of small ice cube at minus 10 Celsius is completely converted into 110 Celsius water vapor. Draw the thermal curve for above heating process. Draw the thermal curve for above heating process. Hari. Draw the thermal curve. Draw the thermal curve for above heating process. Draw the thermal curve for above heating process. Okay, next week we can complete our lesson, heat lesson. Today we can complete quantity of heat. That means second main part. Third main part, very small part, thermal transformation. Thermal transformation we can complete next week. Then final week you have your next exam. Okay, it is simple one. Now minus 10 Celsius make an minus 10 Celsius, I'll erase this part. Minus 10 Celsius water, sorry, ice convert into minus 10 Celsius ice convert into 110 Celsius water vapor. Right. First of all, you can note down this temperature change process flow chart. Then draw the thermal curve. X-axis and y-axis. You have to start from minus level. Minus level. X time, y temperature, starting from minus 10 Celsius, 0 Celsius, 100 Celsius, 110 Celsius. Right. Starting from 0 Celsius, that means time 0 at initially it is minus 10 Celsius ice, right? First of all, it is gradually temperature increase up to 0 Celsius. That's the melting point. Melting point. Melting point. Who complete this? They know? Is it complete? Dulen complete. Others, you met complete? Hari. Hari abbalam hari dekala. You ani complete? Isuru? Okay. Hari. It takes some time at 0 Celsius because it is a melting point. Temperature again increase up to 100 Celsius and take some time. Again temperature increase to final temperature 110. This is the thermal curve, right? It's easy. It is 0 Celsius ice, 0 Celsius water, 100 Celsius water, 100 Celsius vapor, water vapor, right? 110 Celsius vapor, right? This is the thermal curve, right? Now, what is this physical state change? 0 Celsius ice convert to 0 Celsius vapor. 0 ice convert to 0 Celsius vapor. What is this change? It is melting point. Melting. 0 Celsius, sorry, 100 Celsius water convert to 100 Celsius vapor. Hundred Celsius water convert to 100 Celsius vapor without temperature change. Liquid convert into vapor. Liquid convert into gas. Yeah, it is vaporization. 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 Good. Okay, that's the end of thermal curve. Thermal curve means it's a graph to show the relationship of temperature change with time, right? It's a graph to show the relationship of temperature change of any substance with time while heat absorbing or releasing. If it is heat absorbed, starting from this end, it's like a increasing curve, increasing graph. If it is heat releasing, it's just like a decreasing graph, right? Mehen tama start when, right? Okay, that's the thermal curve is done. Let's move into our final part of quantity of heat part, final topic, the mixture method. Mixture method. Mixture method. Mixture method. Mixture method. Okay, actually it is a practical way doing this practical. In heat lesson we have 6 practicals. The mixture method is one of these practical, but the calculation part we doing today practical karaddi api karamu mixture method practical as well, right? It's a very simple practical. And we have specific latent heat practical, and specific heat capacity practical, and mixture method practical, heat transfer practical as well. Pahak තියෙනවා. 5 practicals in heat lesson. Okay, this practical is very easy if you know this specific heat capacity, specific latent heat, mixture method theory knowledge. This practical very simple, right? The same thing we doing as an experiment. එතකොට කරන්න තියෙන්නේ මේ practicals ටික ඔක්කොම යන්නේ same. If you can remember, if you know coordinate geometry basics, easily you can understand all practical, right? The coordinate geometry is the base of practical, each experiment. අපි හැම එකෙම මේ වගේ graph එකක් ගන්නවා. That's the thing, right? In practicals, sometimes this type graph, sometimes this type graph. Y equal mx graph or y equal mx plus c graph. If it is y equal mx plus c graph, it has a intercept plus or minus value. If it is y equal mx graph, it is going through origin, it is intercept 0, right? Let's see in practical class. Hi, mixture method. What's the meaning of mixture method? Now we are going to prepare a mixture. Think a simple mixture. Think it is a water bath. Water bath. Water bath at 30 Celsius, right? 30 Celsius. Okay, I'm going to add heated copper rod, heated copper cube, heated up to 100 Celsius. It's a copper rod. Mix into this water, add into this water bath. Right. Then what happened? Now what happened to the temperature of this system, increasing or decreasing? The final temperature, make a overall temperature increasing or decreasing? The temperature increasing, right? Because heated substance put into the water bath, right? Now, actually what happened? What happened to the water and what happened to the copper cube? What happened to the water? And now think there is no any heat lost. Now think it is a thermal insulated container. No heat loss, right? No heat lost. No heat lost. If it is no heat loss, now this copper cube, heated copper cube, heat absorb or releasing. Make a mix කරාට පස්සේ අපි හිතමු මෙන්න මෙයා මේ ඇතුළේ තියෙන කියලාද? Now it is, think this is a copper cube, 100 Celsius, water 30 Celsius. Okay, copper cube, heat release or heat absorb? Copper cube, heat releasing or absorb? What do you think? Is it heat release or absorb? Copper cube, you mean? Copper cube, you mean? Think again. Now, what is the heat? Heat is the energy which is always flowing from high temperature to low temperature. Right? Then water temperature 30, copper cube 100 Celsius. Now heat energy always flowing from 100 Celsius to 30, right? Then copper cube heat releasing. Copper cube heat releasing. And water, this release heat absorbed by water, right? Water and contains. This release heat absorbed by water and contain. Release heat absorbed by water and contain. Right. Okay, now in this mixture method, we have very simple theory. Very simple theory, simple equation. Okay, think there is no heat lost in the preparation of mixture. Mixture mean we mixing two substance with two temperature, different temperature, right? Substance mixing substance of different temperatures, right? If there is no heat lost, no heat lost. If there is no heat lost in the mixing, that means no heat really, no heat lost released to the environment, no heat released to the environment. Now hot body mean heated object, right? Hot body කියලා කියනවා. Hot body release heat. Hot body mean heated substance always he's releasing in the mixing method, right? In the mixing, heated one is heat releasing because heat always transfer from high temperature to low temperature. Hot body release heat equal to cold body absorb heat. Right? That's the theory. If there is no heat loss to the environment, the hot body heated substance release heat equal to the cold substance absorb heat, because cold substance always absorbing heat, right? But if there is any heat lost, may then mix the heat loss to not think 1 or 2 joules released to the environment. Now it is little bit different. If there is heat lost to the environment, now hot body release heat equal to the heated substance release heat equal to the cold substance absorb heat, cold body cold body absorb heat plus the heated substance release heat, may copper substance 100 Celsius copper cube release heat equal to the water absorb heat plus 30 Celsius water absorb heat and contain absorb heat. That means cold body absorb heat plus heat loss. The amount of heat lost. Remember. right? That's the theory. If there is no heat lost, the heated substance release heat completely equal to the cold substance absorb heat, right? But if there is any heat lost, heated substance release heat equal to the cold substance absorb heat as well as amount of heat lost. Understood? Yeah. Yeah, that's a simple theory of mixture method. If there is no heat loss, uh, the heated substance release heat completely equal to the cold substance absorb heat. If there is heat lost to the environment from the container, the heated substance release heat equal to the cold substance absorb heat plus the amount of heat lost. A heat loss amount add to the heat release heat is equal, right? Hi. Wait. Okay. Go to the tute page number 14. A mixture method, right? A method of mixture is based on the first law of thermodynamics. First law of thermodynamics means a principle of conservation energy. Conservation of energy means the energy cannot be destroyed or create, right? We already discussed the energy conservation law. Actually, the energy conservation is explained in the mixture method because the hot object release heat equal to the cold object. The heat energy, it is a type of energy. It cannot be create or destroy, right? May I release karna equal if there are no heat lost, it is completely equal to the cold cold substance absorb heat. It's explained the energy conservation, right? Conservation of energy, right? It's explained the conservation of energy, right? Okay, when two or more bodies at different temperatures are say mixed inside an isolated system mean no heat lost. Isolated system we can discuss in next phase of thermochemistry. Isolated system mean it's completely thermal, it's completely thermal insulated. It's made by complete thermal insulated. Insulated mean not heat flow into this surface, right? Isolated system, heat energy flow from calorimeter means thermal isolated container, right? Calorimeter. Yeah, this is a type of calorimeter. It's made by insulated heat thermal insulated materials. No heat flow into the surface, right? Heat energy flow from the hot bodies to the cold bodies until thermal equilibrium. Okay, what's the meaning of thermal equilibrium? I already explained the first part of the lesson. First day I explained. Thermal equilibrium means, now think, when it is mixing 100 Celsius copper cube and 30 Celsius water, what happened? Copper cube heat releasing and releasing heat. Now it is thermal isolated. Isolated means no heat loss. Heat loss now think copper cube and water is mixing. Now copper cube heat releasing and the release heat absorbed by water, right? Release heat absorbed by water. Okay, now what happened? The copper cube temperature gradually decreasing, right? Water temperature increasing, and finally it is come to equilibrium temperature. Equilibrium temperature means both substance come to a same temperature, right? ඒ දෙන්නම equilibrium temperature එකට එනවා. That we called as thermal equilibrium, right? Thermal equilibrium. Thermal equilibrium. Okay. At thermal equilibrium, all bodies reach to same final temperature. Yes, all bodies come to same final temperature and no heat transfer occurs. After equilibrium, no heat transfer because both substance same temperature, no heat flowing again, right? I told the heat energy only flowing through the temperature difference. If it is no temperature difference, again no heat energy, right? හරි නේද? අපිට නෝ okay? දිනුල් I got the thermal equilibrium. What's the meaning of thermal equilibrium? Isro? Thermal equilibrium mean if we mixed two substance with different temperature, heat object heat release, and this release heat absorbed by cold substance, and both substance come to same temperature, right? Both substance reach to same temperature. That we called as thermal equilibrium. When it is mixture reach to thermal equilibrium, again no heat flowing because both substance same temperature. Sumit, clear? Nabil? Yes. Okay. The perfectly insulated mean no heat energy flow into the container, right? Heat එක flow වෙන්නේ නැහැ. Then heat lost by hot body, heat lost by hot body mean heat release heat equal to the heat gained by the cold body. Or heat lost by hot body, that means heated substance release heat lost and release කියන එක, heat gained by the cold bodies. Yeah. Okay. The calorimeter is a container, right? No need to remember them. Calorimeter is a container. It's a thermal isolated container. Thermal isolated container, no heat energy flowing through this surface. The ideal calorimeter means perfectly insulated calorimeters, right? Zero heat capacity and heat change with surrounding, no heat change with surrounding. හරි. මේව නම් ඕනේ. Okay, the specific heat capacity example we already discussed. Okay, let's go to calculations. Okay, before that, note down this in a short note. The mixture method, draw this and note down this. Right. Complete. Did not complete. Okay. Now let's move into question number 8 in our paper. The question number 8 to the final question based on mixture method. Hari. Hada. Okay. Question number 8. Yeah, they are actually a lot of exam question based on mixture method. Then mixture method questions hadana. You need all parts we discussed up to now in heat lesson. Quantity of heat part. Ukkama parts tika onide. Right? Okay, question number 8. 200 gram of water at 90 Celsius is mixed with 300 gram of water at 20 Celsius. If there is no heat loss, find the final temperature of the mixture. The final temperature of the mixture asking. Hari. Now, simple. Question number 8. Question number 8. $200 gram of water at 90 Celsius, like this 90 Celsius, 200 gram of water at 90 Celsius mixed with 300 gram of water 20 Celsius. The question asks final temperature. Final temperature means equilibrium temperature, right? You know 90 Celsius water temperature decreasing and heat releasing and temperature drop, and this release heat absorbed by 20 Celsius water, then it is reached to final temperature, equilibrium temperature. Always remember this type question, the final temperature between 90 and 20, because the final temperature less than 90 and more than 20. මේ වගේ answer එකක් තමයි අපිට එන්න ඕනේ. Between 90 and 20. Right? Now, . how to calculate? Now, no heat lost. These questions, no heat lost. No heat lost. It is not given. No heat. If there is no heat lost to the environment, find the final temperature of the mixture. That means equilibrium temperature. Okay, how to calculate? It's very simple. Now, 90 Celsius water, release heat equal to the, if there is no heat lost, hot body release heat equal to the cold body absorb heat. 20 Celsius water absorb heat, right? 20 Celsius water absorb heat. Now 90 Celsius water release heat, 90 Celsius water release heat, 90 Celsius water, 90 Celsius to it is reached to theta Celsius water. Theta Celsius water, right? 20 Celsius water, what happened? 20 Celsius to it increase up to theta Celsius. The 90 Celsius decrease up to theta Celsius, 20 Celsius water increase up to theta Celsius, final temperature, right? Equilibrium temperature. මෙයා අඩු වෙලා theta වලට මෙයා වැඩි වෙනවා theta වලට, finally both come to the same temperature. Right. Now, what happened? Now for 90 Celsius water convert into theta Celsius, then make a theta, I told always answer between 90 and 20, theta between 90 and 20, right? Therefore, no any physical state change. 90, 20 වලට මඩු වුණත් no physical state change, right? Therefore, no problem. MC theta equal MC theta. Now both water specific heat capacity same, C to C cancel. Since both water, right? If it is different materials, you can't cancel out. Since it is both water, specific heat capacity same, 4,200 cancel out, right? The mass of 90 Celsius water, 200. If you want, you can convert into kilogram into temperature difference. That's the most important point. What's the temperature difference? Now 90 and theta, 90 Celsius water convert into theta Celsius. Then what is the temperature difference? What's the temperature difference? 90 convert into theta Celsius water. What's the temperature difference? Now that's the most important point. You have to think 90 or theta is greater value. 90 the theta value temperature. 90, right? I told the theta is less than 90 always. Then the temperature difference 90 minus theta equal mass 20 kilogram 300. So 30 Celsius 300. 300 divided by 1000 to convert into kilogram. Multiply by, what is the temperature difference? You meant 20 convert into theta Celsius. Then theta or 20 is greater value. Theta, right? That's the most important point. Theta minus 20. Theta means equilibrium temperature. Okay, I got this. This is the most important point you need to understand. The others are same. Others are simple. Do I need to explain again? Dule? Nabil? Har. Now, since it is මේ දෙකම grams නිසා අපි cut කරමු 1000 to 1000 200 20 cancel to 20 2 into 90, 180 minus 2 into theta, 2 theta equal 3 into theta, 3 theta minus 3 into 6, 20, it is 60. Right? Now isolate the theta. Now isolate the theta. අපි මෙයා මෙහෙට ගමු. 180 plus 60 equal 3 theta plus 2 theta. 3 theta plus 2 theta. Right? 180 plus 60, 240. 240 equal 5 theta. මෙතන 3. නෑ මෙතන 3. Right? 5 theta. Now theta equal 240 over 5. 240 over 5. 240 over 5. 240 over 5. 48 Celsius. 48 Celsius is the answer. Right? I told it's always between 20 and 90. Yeah, 48 Celsius is acceptable. I got this. Yeah, that's why I told you need all quantity of heat knowledge to do this type mixture method question. Any doubt? Any doubt? Okay, complete. Younger. Okay, let's move to question number 9. Yeah, 9 also very important. I'm going to erase this. Yeah, 9 same type, no? Okay. 0.5 kilogram of aluminium piece at 100 Celsius is mixed with 1 kilogram of water at 20 Celsius. Calculate the final temperature of ignoring the heat loss to the surrounding. Think no heat lost. The question asks final temperature of the mixture. Hurry. But one data is missing. Data එකක් කඩුයි. Write down specific heat capacity of aluminium. Specific heat capacity of aluminium. Specific heat capacity of aluminium. (2800 JkG minus 1 K minus 1). 2800 JkG minus 1 K minus 1. This is a specific heat capacity of aluminium. Hurry. Hurry. Hadu. Okay, now what is a hot body? Now aluminium release heat. Now heat, no heat lost. Aluminium release heat. Okay, how the answers? The final temperature. The aluminium release heat equal to the water absorb heat, right? Water absorb heat. Water absorb heat according to mixture method, right? Heat. Now, aluminium release heat mean 100 Celsius aluminium convert into theta Celsius, right? Water 20 Celsius water convert into theta Celsius. Theta Celsius, right? Same type. But the thing is now it is different substance. Different substance means you can't cancel out any data. Specific heat capacity then MC theta equal MCW means specific heat capacity of water theta equal to no heat loss. Therefore, not water, aluminium. MCW water theta. Substitute mass of aluminium 0.5 kilogram. 0.5 kilogram, right? Aluminium specific heat capacity 2800 JkG minus 1 K minus 1. Temperature difference. Hurry. Can you send me the temperature difference? Dole. Temperature difference of aluminium rod. Very good. 100 minus theta. Good. 100 minus theta because no any temperature physical state changes. Equal 20 Celsius water maximum reach to 100 Celsius. Therefore, no vaporized, no physical state change. Mass the water 1 kilogram. 1 kilogram into 4200 is a water specific heat capacity. 4200 J kg minus 1 K minus 1. Temperature difference for water, you met. The temperature difference for water, you know. Temperature difference for water. Great. Dule. Yoni. Great. Theta minus 20 because 20 and theta is a greater value. Theta value 20 volt. Then theta minus 20. Theta minus 20. Theta minus 20. Good. Okay, now you can solve. 2800 into 0.5 mean half, it is 1400. 1400 into 100. 1400, two zeros, minus 1400 theta. Right? 1400 theta. Now equal 1 into 4200, 4200, 4200 into theta, 4200 theta. Minus 4200 into 20, method 84 and 3 zeros. Correct. Right? Now you have to isolate the theta. Theta ka isolate karamu. 140,000 add karamu 84,000. 140,000 add to 84,000 equal 4,200 theta add into 1,000. 1,400 get into this side. They are plus 1,400 theta. Correct. Now 140,000 plus 84,000. What's the value? Correct, right? 224,000. To 4,200 plus 1,400. 0, 0, 6, 5. 5,600 theta. Now theta equal to 224,000 divided by 5,600. Value look at that. 40 Celsius growth. 2020 cancel out 40 Celsius. Great. 40 Celsius. The final temperature 40 Celsius. Good. Okay, question number 10 for homework. Api venas sidika khada make same type question. Homework. Note down. Question number 10 for homework. Question number 10 for homework. Question number 11 also homework. Same type. ඒ විදියම එකක්. Let's do question number 12. Question number previous two questions 10 and 11 homework. අපි හදමු 12. A metal container contains 2 kilogram of water. Metal container contains 2 kilogram of water at 30 Celsius. When 5 gram mass of copper is placed in this vessel, the final temperature was 50 Celsius. Find the specific heat capacity of copper. Wait, there's a problem. Steam. A metal container contains 2 kilogram of water at 30 Celsius. Okay. When 5 gram of there is a problem. A metal container contains 2 kilogram of water at 30 Celsius. When 500 gram of mass at 100 Celsius. Please correct that. When 500 gram mass copper, sorry, 500 gram of copper at 100 Celsius. At 100 Celsius. එක temperature එක දෙන්න ඕන. At 100 Celsius is placed in this vessel. Right? Copper substance is added into this water bath. Right? The final temperature was 50 Celsius. The final temperature is given. Right? Final temperature was 50 Celsius. Find the specific heat capacity of the copper. Find the specific heat capacity of copper. The specific heat capacity of water is given. මෙතන තව දාගන්න වෙනවා අපිට heat capacity. Heat capacity of container. $500 JkG minus 1. හරි. ඉස්සෙල්ලා question එක හදාගමු. First, correct the question. A metal container contains 2 kilogram of water at 30 Celsius. When 500 gram of copper at 100 Celsius is placed in this vessel, the final temperature was, that means equilibrium temperature, 50 Celsius. Find the specific heat capacity of copper. That means copper specific heat capacity is asking, right? The specific heat capacity of water 4200, you already know. Heat capacity of container 500 JkG minus 1. Hari. Question is okay? Hari. මේක ලියාගත්තත් කමක්. Okay, I'll give you 1 minute. Note down the question. Hadam? Yeah, it's a very good question. This type questions always ask. Okay, actually, this is a purpose of mixture method. This is a purpose of mixture method. Maybe now, actually, the mixture method purpose is not the calculate final temperature. That one also calculation type. But the ultimate, the purpose of mixture method, think, මෙන්න මේක තමයි purpose එක. Right? We have non-water bath. අපි දන්න water bath එකක් ගන්න. Right? Non-water bath. In practical classes, we can discuss. Think it is non-water bath. The temperature we can measure and mass we can measure. Right? Think we have unknown metal part. Unknown metal part, we don't know specific heat capacity. Right? Metal part එකක් තියෙනවා. We don't know material type or specific heat capacity. Right? Then we can heat these up to 100 Celsius. Make up 100 Celsius heat color, then put into this water bath. Finally, we can get the final temperature of this mixture. Now, according to this question, 50 Celsius is a final equilibrium temperature. Now, think water temperature 20 Celsius, right? Then using mixture method, we can calculate the specific heat capacity of unknown matter, unknown material or metal. Now, which substance heat releasing? It's a metal, right? Metal cube release heat equal to the water and container absorb heat. The thing is water and container both absorbing heat. That's the thing. Metal releasing heat, release heat equal to the water plus container absorb heat, because water and container both at initial temperature. Okay, the water and container both initially water and container both 30 Celsius. Water absorb heat plus container absorb heat. Water and container absorb heat. Right, no heat lost. Right. The metal release heat. What's the equation? mc theta. Because no heat lost, no heat lost and no physical state changes. Metal like a water in that. Water and container absorb heat. Water absorb heat, it's a metal. Water absorb heat, mcw, water, theta. Plus container absorb heat also mc, not mc theta, c theta, because heat capacity given for container, c theta. Why you use heat capacity? The container heat capacity is given, right? Container ke dila thiyenne heat capacity. Right. Now mass of the metal cube, it is 500 grams. 500 grams. 500 gram means 0.5 kilogram. Now C metal, unknown metal, specific heat capacity don't know. Cm කියලා දාමු. It's don't know. Done. Temperature difference. What's the temperature difference? Can anyone send? Now metal cube is 100. 100 Celsius to theta Celsius. Now the final temperature already given. 50 Celsius. Here the difference. No, you wait. The final temperature already given. The equilibrium temperature given. Now that's the difference. Equilibrium temperature already given me. The final temperature was 50 Celsius. Then 100 minus 50. Then deal 100 minus 50. That is the difference, right? 100 minus 50, it is 50 Celsius. That's the temperature difference, right? Now, MCW, M mean water mass. Mass of water. 2 kilogram of water. 2 kilogram. CW 4200. 4200. Water specific heat capacity. Temperature difference. Temperature difference. Temperature difference. Temperature difference. Water. Uni. Temperature difference of water. 20 Celsius නේද 20 Celsius water කීයට යනවද yeah initially sorry 30 Celsius water කීයට යන්නේ final temperature it is 50 Celsius then what is the temperature difference 20 yes 30 initially it's increased up to 50 right අදට තේරුම් ගන්න it is 20 Celsius is a temperature difference plus heat capacity of container. Container also absorbing some heat. Heat capacity of container 500. Temperature difference for container also 20 because it is same temperature difference with water. හරි. මේ අපි හදාගමු 0.5 into 50 25 into cm. cm mean metal specific heat capacity. 2 into 4200 into 20. What's the value? 8,400. 8,400 into 20. What's the value? 4,200 into 40. 168,000. Joules plus 500 into 2,000. 10,000. 10,000 joule. Now 25 CW. cm. Sorry. cm means specific heat capacity of metal. 168,000. 178,000 joule. Now cm equals 178,000 divide by 25. Answer you met understood get the value okay actually this is the purpose of now it is 7,120 is the jkg minus 1 now you have to remember the specific heat capacity unit jkg minus 1 k minus 1 joules per kilograms per Kelvin joules per kilograms per Kelvin Dulen clear now this is the actual purpose of mixture method now the final temperature already we can find in the practical of experiment of mixture method right finally we can find the specific heat capacity of unknown material by mixture method මේටික මෙන්න මේ දැන් mass මෙන්න මේ ටිකනේ අපි දැනගන්න ඕනේ බලන්න mass of metal we can measure right mass of metal we can measure the temperature difference we can get by final temperature කරගෙන ගන්න පුළුවන් final temperature and initial temperature mass of water we can measure right mass of water specific heat capacity of water already know temperature difference of water we can measure final temperature and initial temperature of water heat capacity of container we can use non heat capacity container right calorimeter එකක් use කරන්න පුළුවන් lab එකේ temperature difference of container also equal to water temperature difference right okay then we can isolate unknown metal specific heat capacity I got Bianca Giovanni I got Cm mean metal specific heat capacity, right? Hari. Make I gave you two homework 10 and 11. 12 අපි කරා. Specific heat capacity of water. Let's do question number 13. 13 අපි හදමු. Okay, 100 gram of ice at 0 Celsius. 0 Celsius ice added to 200 gram of water at 30 Celsius. It's an interesting question. Now, 0 Celsius ice mean they already in the melting point, right? එයාලා දිය වෙන temperature එකේ තියෙන melting point. Now 100 gram of ice add into 200 gram of water container 30 Celsius. Then what happened? First ice melted and it's reached to final temperature, equilibrium temperature. It's a good question. The specific latent heat of fusion of ice is given. The specific heat capacity of water is given. Find the final temperature of mixture. Hari. Then make a normally in practically if we add ice cubes into water, the temperature drop and come to reach to final equilibrium temperature. තිහට වඩා අඩු උෂ්ණත්වයක තමයි temperature එකක මේක stable වෙනවා. It's come to stable temperature, equilibrium temperature, right? හරි. හදමු. Now they don't have given about the container, right? Container ගැන දීලා නැත්නම් අපි හිතන්න ඕනේ නැහැ. No need to consider. Now, now, which substance heat release, ice or water? Dule. Heat releasing by ice or water. How the heat release kara? Ice or water? So it's releasing heat. Now 100 gram of ice cube at 0 Celsius add into 200 gram of water cube at 30 Celsius. Now which one heat release? Yeah, water heat release. Water release heat equal water release heat equal to the ice absorb heat. No? Ice absorb heat. At this point, you have to be very careful. Harida. This is a point you have to very, very careful. Balanda. Water release heat mean 30 Celsius water reach to theta, equilibrium temperature water. No problem, no physical state changes. But ice is not like that. Ice මොකද වෙන්නේ? Ice temperature increasing. 0 Celsius ice convert to 0 Celsius water first. Melting. Finally, it is reached to theta Celsius water. Now, for water release heat, it is MC theta. Only MC theta because water only temperature පොඩ්ඩක් අඩු වෙනවා විතරයි. Only temperature drop. But ice, it is totally different. Ice first need to melt and increase temperature up to theta Celsius. I got this story. Let's say I told for mixture method calculation, you need complete full knowledge of quantity of heat. You met okay? Yeah. 0 Celsius ice, 0 Celsius water, ml plus 0 Celsius water, theta Celsius water, mc theta because temperature difference. mc theta. Hari. Hari. Hadamu. Mass of ice. No, water. Mass of water. Mass of water. 200 gram of water. 200 divide by 1000 to convert into kilogram. 4200 is the specific heat capacity of water. But the problem is, what is the temperature difference now? All can we have 30 Celsius water come to equilibrium theta temperature. What's the temperature difference? -30 minus theta. Very good. Because 30 is the greater value. Very good. 30 minus theta. That's very, very important. 30 minus theta. The mass of ice 100 gram. 100 divided by 1000 or 0.1 kilogram. Multiplied by specific latent heat of ice at fusion. Fusion can it melting, right? Fusion means melting. It's a similar word. Similar word. 3.34 into 10 to the power 5. 3.34 into 10 to the power 5. 3.34 into 10 to the power 5. This is MLD equation. Plus, not multiplication. Plus MC theta. MC theta mean ice 100 over 1000. Specific heat capacity same 4200. No. It is now not ice, water. Water will then, but mass 100 gram. 100. Specific heat capacity 4200. Temperature difference. Temperature difference. We have the, what's the temperature difference of 0 Celsius water to theta Celsius water? After melting. Melt velati. Yeah, that's an important point. Then what's the temperature difference? You meant. Yeah, theta minus 0. Because theta is greater than 0. Theta minus 0. Great. Now you can isolate the theta. 20 cancel out. Method 0 then 420 into 2, 840. 840 into 30. Tagal done. 840 into 30. $25,200. 25,200 minus 840 into theta, 840 theta equal 20 cancel. Now it is 0.3 0.334 334 two zeros, correct? Adibal. Two zeros, yes, correct. Plus, plus 20 cancel, 0 cancel, 420 theta minus 420 into 0 means 0. एक alone. Now you can isolate the theta. Simple. Isolate the theta. Isolate the theta. 25,200. Get this part is subtracted. No? 25,200 yeah, correct. 25,200 minus 33,400 equal 420 theta plus 840 theta. Don't think about this minus in net temperature. Get this difference. $8,200 minus 8,200 equal 420 plus 840 to 1,260 theta. Okay. Sorry, there is a problem here. Now 20 cancel. It is 42 theta. No, correct. Yes, correct. Now you can get the temperature. 8,200 divided by 1,260. 6.5. 6.5. Theta equal, not minus, 6.5 Celsius. Understood? 6.5. 6.5. Final temperature, the 30 Celsius. 30 Celsius water dropped up to 6.5 Celsius due to ice cube. Ice cube. Understood? Because it is only 200 gram of water. Right? Clear? Yeah. Don't need negative sign because the temperature
always plus value in 0 Celsius ice mixing. Metan minus Na yeah, steps correct. Yeah, we can neglect the minus sign. 6.5, not minus 6.5, 6.5. Okay. You met? Understood? Okay, question number 10, 11 homework. 10, 11 homework. 12, 13 discussed. Question number 14, 15, 16, 17 homework. Pull out the remain questions. You have 1, 2, 3, 4, 5, 6. Only 6 questions. Same type questions. Some questions giving different physical state change, vaporization, condensation, different physical state change. But in these cases, you have to carefully apply the same mechanism, same principle, and get final temperature or unknown value, right? Unknown value. If it is asking specific latent heat or whatever another substance, the final temperature is given, right? Methane. The temperature of system 50 Celsius. The final temperature is giving, right? Final temperature when එකක් අහනවා නම් දෙනවා. The final temperature is 5 Celsius, right? They are giving. Hi. Okay. That's the end of second main part of heat lesson, quantity of heat. Next day I will discuss these remain questions and go to the thermal transformation. That's the end of heat lesson. That's the end of heat lesson. We did now this is the 8 parts of 7 part. Up to 8 part again. Okay. Any doubt? You any? Okay, then let's meet next Saturday evening with our question discussion. Okay, goodbye. Oh, sorry, you met? What the hell? Why did we got a minus before? Minus before mean where? Previous question. Yeah, because 25,200 minus 33,400, it's a minus value. It's a minus value. Practically minus එකක් එන්නේ නැත්තේ කියලා අහන්න. Because ice temperature 0, water temperature 30. Always final temperature should be between them. 0 and 30. Then minus 6 is not practical, right? Minus 6.5 not practical. That's why I got 6.5. Okay. You can mind 0 to what are doing, right? Okay, goodbye.